Chapter 6, Section 1, What are waves? The two main questions that we need to answer through this section are what forms mechanical waves and what are the types of mechanical waves. What forms mechanical waves? You have probably seen and felt water waves while swimming, but did you know that many kinds of waves affect you daily? Sound and light are very different from water waves, but they are waves too. Characteristics of waves. What is a wave? A wave is a disturbance involving the transfer of energy from place to place. In science, energy is defined as the ability to do work. For example, the energy of a water wave can lift an object on the water's surface as the wave passes under it. But after the wave passes, the water is calm again. Most waves need something to travel through. For example, sound waves can travel through air, water, and even solid materials. Water waves travel along the surface of the water. A wave can even travel along an object such as a rope. The material through which a wave travels is called a medium. Gases, such as air, liquids, such as water, and solids, such as ropes, can all act as mediums. Waves that require a medium to travel are called mechanical waves. Waves and energy. Energy is needed to make a wave. Mechanical waves form when a source of energy causes a medium to vibrate. A vibration is a repeated back and forth or up and down motion. Moving objects have energy which they can transfer to a medium to produce waves. For example, as you see in Figure 1, a motorboat's propeller can transfer energy to calm water. As a result, the particles that make up the water start to vibrate. The vibrations move through the water, resulting in a wave. What are the types of mechanical waves? Waves move through mediums in different ways. The three types of mechanical waves are transverse waves, longitudinal waves, and surface waves. These waves are classified by how they move through mediums. Transverse waves. When you make a wave on a rope, the wave moves from one end of the rope to the other. However, the rope itself moves up and down or from side to side at right angles to the direction in which the wave travels. A wave that vibrates the medium at right angles or perpendicular to the direction in which the wave travels is called transverse waves. Making a transverse wave on a rope forms high and low points along the rope. The high points on the transverse wave is called the crest, and a low point is called a trough. In Figure 2, you can see that the red ribbon on the rope is first at the crest and then at the trough. As the waves move through the rope, the ribbon moves up and down between crests and trough. The dashed lines show the rope's position before it was moved. It is called the rest position. Longitudinal waves. If you push and pull one end of a spring toy, you can produce a longitudinal wave like the one shown in Figure 3. Notice that the coils in the spring move back and forth in the same direction or parallel to the wave's motion. A longitudinal wave vibrates the medium in the same direction in which the wave travels. Also, notice how the spacing between the coils varies. Some coils are close together, while others are far apart. An area where the coils are close together is called compression. An area where the coils are spread out is called rarefaction. As compression and rarefactions travel along the spring toy, each coil moves forward and then back. The energy travels from one end of the spring to the other in the form of a wave. After the wave passes, each coil returns to its starting position. Surface waves. Surface waves are combinations of transverse and longitudinal waves. This type of wave travels along a surface that separates two mediums. Ocean waves are the most familiar surface waves. An ocean wave travels at the surface between water and air. When a wave passes through water, the water and anything in it vibrate up and down, like transverse waves on a rope. The water also moves back and forth slightly in the direction that the wave is traveling, like the coils of a spring. But unlike the coils of a spring, water does not compress. The up and down and the back and forth movements combine to make each particle of water move in a circle, as seen in Figure 4.